Last time we helped our tiny switch to handle more power. But what happened if you suddenly cut off that power? Normally, everything just shut off instantly. Today, we will use one of the simplest components in electronics to make our LED gracefully fade out when power is cut: the capacitor. A capacitor stores electrical energy a bit like a tiny rechargeable battery. The bigger the capacitance, the more energy it can store, and the longer it can release that energy. Electrolytic capacitors like this have positive and negative sides. The longer leg is plus and shorter leg is minus. Also, they usually have markings on them showing where is the negative side. For this kind of timing and slow fading, electrolytic capacitor work best because they offer high capacitance in a small package. Ceramic and film types are great for small, fast signals, but here we want more storage. Capacitors also have max voltage. Usually it's written on the side, where is capacitance. For example, this one is 470 microfarads and 25 volts. Always choose capacitor with something like 1.5 or 2 times voltage you have in your circuit. So for example, for our 3 volt circuit, we will choose something like 6 volts capacitor. This way you will be sure that you will not blow up your capacitor. To make our LED slowly fade out, we will connect our capacitor between ground from battery and gate from MOSFET, just like our pull-down resistor. That way, when we turn off a switch, the voltage on the gate will be dropping down slowly and MOSFET will be closing slowly. That way the LED will fade out. Now I will show you the difference with scope. First, we will connect ground to the ground and signal to gate from MOSFET. Okay, let's turn on and let's see. Okay, it looks like this. Now let's turn off. You see, it's instant shutdown. The line is dropping down in straight line. Now let's turn off and we will connect our first capacitor. It's 10 microfarads. Shorter leg to the ground, longer to gate from MOSFET. Like this. And let's turn on. Let's see. It's working. Now let's turn off. You see? Now the line is not straight it curve a little bit, but it's still fast and you cannot see it on LED. Even with the capacitor, it turned off pretty quickly, so it's not visible, but on the scope you can see it. Now let's check next one. This is too small and it's too quick. Now let's take our 100 microfarads. Let's connect it the same way. Let's turn on. Let's see. It's working. Now let's turn off. Now you can clearly see the big curve, and you can see on LED clearly the fading out. Okay, let's check the last one I have, and this is 470 microfarads. Let's connect it. Okay, turn on. Let's see, it's working. Now let's turn off. Now the curve is even bigger, longer, and LED is fading out a lot longer. Even when I turn on, you can see it's turning on a little bit slower. It's not instant. And I think this capacitor is too big. We will use our 100 microfarads because I think it's the best. It's not too long and not too quick. You can see the fade out, but it's not too long. So we will connect it back, and now we have it, slowly fading out LED. So next time you want something to fade out instead of snap off, add a capacitor. It's one of the simplest and most satisfying upgrades you can make. In the next video, we will learn how to measure current, voltage and other things using a multimeter, an essential tool for any electronic project.